Now, the next subtopic is a precursor to the first law, Newton's first law of motion. So, Galileo came before Newton and he conducted an experiment, a very interesting experiment. What he did was he made an inclined plane and he tried to make it very smooth, and he made it smooth by greasing it. Now, how did all this the idea of an experiment come to Galileo's mind? There is a story behind that. Now, what people thought is when you roll a ball on the ground, it rolls to a certain distance and then it stops. Now, people at that time had a misconception. They thought that when a ball is rolled on a table and it comes to rest, because there is no absence of force. When you roll a ball and you leave it, you might have a misconception that no force is acting on that ball, because nobody is touching it and there is no magnet, there is no electric force, there is no gravitational force in picture here, because you are rolling it horizontally, so the earth cannot pull it down. So there is no non-contact force acting on the ball, there is no contact force acting on the ball, visible contact force. So probably the ball stops because there is no force acting on it. So there is no force, there is no acceleration, so ultimately the ball stops. But this was a misconception. If you made this table very smooth, the ball is not going to stop. If you keep on making it smooth until a time when you can call it almost frictionless, the ball is not going to stop. If you roll it, it will keep on rolling with a constant velocity through indefinite distance. Now, when this particular thing was taken up by Galileo. So when people said that the ball stopped because there was no application of a force, Galileo wanted to conduct an experiment and check whether that was true. So what he did was he took an inclined plane, he greased it. When you grease it, you reduce the frictional forces, and he greased it to make it very smooth. He rolled a ball from the top of the incline. When he rolled the ball went up, the ball rolled down, and then he also put an incline. As you can see in the figure, he put an incline on the other side. So there was an incline from which he rolled the ball. There was some smooth horizontal surface, and then again there was an incline, as you can see in the picture. Now, when the ball was rolled, the ball rolled down the incline, it traveled horizontally, and then it went up the other incline. And he was surprised to find that the ball went to the same height on the other incline from which it was released from the other incline. So if you can see in the image, if from a height h he released the ball, it went up on the other incline up to a distance h. So after that, what he did was he reduced the slope of the second incline. So he kept on increasing the slope. As you can see in the second figure, the slope of the incline is reduced. And then he rolled the ball. When he rolled the ball rolled down and then it went up. It continued to move until it reached the same vertical height from which it was rolled down from the other incline. So he kept on doing it. He kept on reducing the incline, the slope of the incline, and ultimately he reached at a point where he made it completely horizontal. And in that case, he observed that when the ball was rolled, it moved indefinitely. It did not stop. It moved to a great distance. So he figured out that as the slope of the incline was decreased, the ball moved greater distance before stopping. So when there was no force acting on it, in the earlier case, when the ball stopped, the rough surface of the table stopped it. So there was a frictional force acting on that ball. But when you made the surface of the table very smooth, the ball did not stop. And when you made it very smooth, there was no force acting on it. There was no contact and there was no non-contact force. So obviously there was no external force acting on that object. And when no external force acted on an object, it continued to retain, or it continued to move in the same state of motion as it was. So this formed the basis for Newton to formulate his first law of motion. And now let us see how he actually took up Galileo's experiment and his laws to actually formulate his first law of motion. What does Newton's first law of motion state? It states that an object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied unbalanced force. Why are we saying unbalanced force? Because if the forces are balanced, then the net effect of the forces would be zero. So for an object, for any object to remain in a rest or to retain its uniform motion along a straight line, it continues to do that unless it is acted upon by an unbalanced force. And if no unbalanced force acts on the body is said to be in equilibrium. If it is in a state of rest, it will stay in a state of rest. If it is in a state of uniform motion, it is going to continue in a state of uniform motion. So this is what the Newton's first law states. And from the Newton's first law of motion, a very important concept of inertia came. Now what is inertia? Inertia is the tendency of a body to resist a change in its state of rest or of uniform motion. So whenever you have a body, it by default it tries to maintain its state by itself. So the tendency of that body is the amount of tendency, the tendency that any body will have to resist a change in its state of rest or uniform motion is called the inertia of a body. And if you want to give it a figure, so if you want to say talk about inertia in quantitative terms, inertia is the measure of inertia of a body is called mass of a body. So greater the mass of a body, greater is its inertia. So you have a huge boulder of rock, a rock boulder, it will have greater inertia than a small stone, because the tendency to maintain its state of rest in case of big boulder is going to be too high than a small stone. If you just give a small tap to a small stone, it might move, but if you are going to apply a great force on the big boulder, probably then also it will not move and it will resist the change of its state of rest. So the greater the mass, the greater is the inertia of the body. And what is inertia? Inertia is the tendency of a body to resist a change in its state of rest or of uniform motion. Now the first law of motion, if you just go ahead and revisit it after learning the definition of inertia, what you see is that a body remains in a state of rest or of uniform motion unless it is acted upon by an external force. So there is a sense of resistance, and that is called force. So the first law of motion is also called the law of inertia, and there are three kinds of inertia that we will be studying. Basically there are two. Some people refer to the inertia of direction as the third inertia, but generally there are two types of inertia, which is the inertia of rest and inertia of motion. We will also be looking into the inertia of direction, where a body also resists the change in direction, and we will be taking up a few examples to explain to you what exactly inertia of direction is. So now let's move. So let us now understand the inertia of rest, motion and direction in a bit deeper through examples. Now what is inertia of rest? Inertia of rest would be the tendency of a body to resist a change in its state of rest. Now an example would be when you are sitting in a train and the train suddenly moves. You feel a jerk, you move. And why is that so? It so happens that when you are sitting in a stationary train, your body, your legs are in contact with the stationary train. When the train suddenly moves, the lower portion of your body moves with the train, but the upper part of your body that's not in direct contact with the train, that has already started to move, it tries to maintain its state of rest. So when you are sitting here, your lower body moves along with the train, but your upper body resists that change. So your upper body tends to fall back and your lower part of the body moves in the front. So there is a jerk that you experience. For example, you play a game of carom. So when you pile up the coins and you hit the bottommost coin with your striker, what happens? It just moves out of the whole pile and the rest of the pile stays like that. Now what happens there? When you apply a force, the lowest coin experiences that force and it moves. But the rest of the pile with all the other coins, they try to retain or maintain their state of rest due to inertia of rest. So they stay at their own position. So they just stay wherever they are. So this is what inertia of rest is. Now you think about what happens when a person cleans his carpet by hanging it and beating it. When he beats his carpet, the dust particles along with the carpet were initially at rest. So when he beats it, the carpet moves back. But the dust particles want to maintain their state of rest and hence they stay at the same position. The carpet moves back and the dust particles fall down. So that again is an example of inertia of rest. Now inertia of motion is the is the tendency of a body to maintain its state of uniform motion when acted upon, unless acted upon by a force, and that is inertia of motion. So this particularly happens when you're going in a bus and the driver suddenly applies brakes to the bus. What happens? You again experience a jerk, and this time what happens? Instead of going back, you move forward. Now why do you move forward? This is because the lower part of the body and the upper part of the body, when it is moving, it's going forward. When the brakes are suddenly applied, the lower portion of your body just stops, but the upper part of the body, it tries to retain or maintain its state of uniform motion going forward, and it moves forward. So you tend to move forward whenever the driver applies a brake. You tend to move forward, whereas when there is a train that suddenly moves from a stationary station, you tend to fall backwards, because in that case your lower part of the body moves ahead, while your upper part of the body stays at its place. So there is a feeling that you are moving backwards. So that's an example of inertia of motion. Now inertia of direction is, I'll give you an example. When you're going in a hilly area in your car, and your car is going straight, and then suddenly there is a sharp curve, and the driver takes a sharp curve, you tend to fall on the other side. Now what happens? When you're going in a straight direction, your body is accustomed to moving straight, so your state of motion is in the forward direction. When you suddenly make a right turn, the lower part of your body moves towards the right, but the upper part of the body, which is still trying to maintain its state of motion along the forward line, moves towards the forward line. So there is a feeling that when you're turning right, you go left. You're essentially trying to go forward along the straight line that you are traveling from, but there's a feeling that the car has turned right, but you are falling to the left, and that is an example of inertia of direction. So people also, or things, would also try to maintain state of direction. So if you're going forward, you try to, your body will be accustomed to, and it will try to maintain its state of direction in the forward direction, and if you suddenly change the direction, you will experience a effect because of the inertia of direction. Now after understanding the inertia, the three inertia that we have, now let us move to understanding what the Newton's second law of motion is, and also understand an important concept of momentum. So let's now see